In this video, we're going to discuss the practice problems for proven identities. And the first practice problem, which was number 11, was pretty simple. All what you had to do is write cotan as cosine over sine. And this way you can see how you can simplify the signs together. You could go with this in different routes. Again, there's no one way of doing this, but I would say if you distribute, that would be the easiest, because when you distribute, you can see when we distribute, we multiply. So we can simplify across. You're left with a sine, and cosine multiplied by cosine is cosine square, and that's exactly what you needed on the other side. Number 12 is very similar. Write the tan as sine over cosine, simplify across, then distribute. When you distribute, you can simplify across for the first term, and you get cosine plus sine squared, and that is the right side of the identity. That was number 12. I did hear a quick review of special cases because you would definitely need those in the problems. We'll go back if needed, but that was the intention for it. So 1 minus tan squared equal this. Again, we need to take one side, do some work, some algebra with that to show the other side. So I used the special identity. Let me see, I numbered them. So I used number 2 because you can see parentheses and a square. I use number 2, which will be a squared, so first term squared, minus 2 multiplied by first multiplied by second. So 2 multiplied by 1 is just 2, multiplied by 10 is 210, plus b squared, so last term squared. 1 plus tan squared is secant squared, and that's what we need, and minus 210, and it's done. Second one, which is 14, very similar. I use the same identity, cosine squared. So first term squared, minus 2 multiplied by first multiplied by second. So 2 cosine sine, plus sine squared. Cosine squared plus sine squared is 1. 1 minus 2 sine cosine, or cosine sine. It doesn't matter. If you're multiplying, it doesn't matter about the order. And let's see, is that what we needed? 1 minus 2 sine cosine. Yes, 1 minus 2 sine cosine. That was number 14. Number 15. Again, you take, if you want to take a look at number 15, you can see there's something to use right here. Again, special identity, a minus b, a plus b, which turns into a squared minus b squared. So 1 squared is 1 minus cosine squared over cosine squared. And 1 minus cosine squared, identity 10, is sine squared. So sine squared divided by cosine squared is tan squared. That's what we were looking for. I think I just messed up with the order, but that's fine. I did 17, 18, then I did 16 on that slide. That's fine. Okay, cosine squared minus 1. You can see identity 10 is 1 minus cosine squared. So if I flip it around, it will give me sine squared, but with a negative because it's flipped around. Okay? Divided by cosine. So this will be a negative tan as we were looking for. But this has a sine squared. So I'm going to split it up to sine and sine. Sine multiplied by sine. And I'm going to put next to the sign the negative, because that way I can get that negative 10. So negative 10 multiplied by sine. Again, let's double check. Negative sine multiplied by sine is negative sine squared over cosine. Okay, so this is exactly what we needed. I showed you right here how 1 minus cosine squared is sine squared. But if you do cosine squared minus 1, you're bringing the sine squared to the other side, and that's why it's a negative sine squared. So kind of showing you the difference between this, which gives you sine squared, and between this, which gives you negative sine squared. Number 18, secant squared minus 1 is tan squared over sine squared. And tan is sine over cosine. Since it's squared, they're both squared over sine. Keep, change, flip. So I put this over 1. I kept the first, multiply, flip the second. sine and sine squared cancel out to sine. And the bottom is cosine squared. If you can't see it right here, it's cosine squared. So I look at what's given, and they don't want me to write cosine squared. They want 1 minus sine squared, and it's the same. It's an identity. Derives from identity 9, from the Pythagorean one. So this is pretty simple as well. Last one, which is 16. Tan plus secant. So tan is sine over cosine, and secant is 1 over cosine. They have the same denominator. No need for a common denominator. That's why I can write them together using one fraction. I can multiply this, kind of the idea of trying, look at the other side. The other side has a cosine, but I have a sine right here. They're kind of flipped, if you can see. This one is 1 plus sine. This one has 1 minus sine. So I'll multiply top and bottom by 1 minus sine. That way I can get 1 minus sine squared. This is an identity, a plus b, a minus b. So a squared minus b squared. And 1 minus sine squared is cosine squared. That way I can show a cosine on top, and cosine multiplied by 1 minus sine on the bottom. Once I get cosine squared with a cosine on the bottom, it simplifies just to cosine and divided by 1 minus sine. So again, what we did, we multiplied the top and bottom by 1 minus sine. Why? Because it shows right here, and I did not get it when I rewrote tan and secant as sine over cosine and 1 over cosine. So I didn't see what I wanted yet. It's similar to the idea of multiplying by a conjugate in imaginary numbers, if you guys came across that in Algebra 2. Also similar to the idea, if you want, of rationalizing. That's why we multiply top and bottom by an expression that didn't show yet, but we need it.